Hello, today I'm going to talk to you about the issue of antibiotic resistance and how it affects human health. This is the outline we will follow today. So first of all, what is antibiotic resistance? Before anything, we need to know what is an antibiotic. Antibiotics are drugs used to treat bacterial infections by killing bacteria cells while causing the least side effects to body cells. Antibiotic resistance develops when bacteria develop the ability to circumvent antibiotics and continue to grow. When this happens, the antibiotic is no longer effective at treating disease. It is a very significant problem the world is facing today. Presently, many medical procedures depend on antibiotics for patient survival, such as healing surgical wounds, cancer chemotherapy aftercare, and to treat complications in childbirth, to name a few. If antibiotics become useless, millions of people can die when many medical procedures become impossible. As we can see from this chart taken from WHO, at present, 700,000 to several million deaths result each year from antibiotic resistance-related complications. This number will likely only increase if preventive measures are not taken. But how do microbes naturally become resistant in the first place? Among the bacteria naturally existing in the environment, there exists a natural variation in susceptibility to antibiotics. Some individual bacteria, as you can see here in red, possess a genetic mutation which gives them the ability to resist an antibiotic. When antibiotics are used, it can kill off all the bacteria except those with the resistant gene. This generates a selection pressure favoring the resistant bacteria. Additionally, since antibiotics kill off all germs including the non-disease-causing ones, this lowers competition for the resistant bacteria and they thrive. As a result, without competition, the resistant bacteria can grow very quickly. By vertical transfer, they pass the resistant genes to the next generation. Eventually, they can take over the original non-resistant population. Furthermore, some bacteria can give their resistant genes to another bacterium. They do it through horizontal transfer, that is, injecting their genetic material in the form of a plasmid into another bacterium. This way, antibiotic resistance can spread in the environment very quickly once a genetic mutation for resistance has occurred. So what is making antibiotic resistance a global crisis? There are several factors contributing to a global environment that favors antibiotic resistance. They are: firstly, the overuse of antibiotics. In many countries, antibiotics are unregulated and available over the counter without a prescription. This lack of regulation results in antibiotics that are easily accessible, plentiful, and cheap, which promotes overuse. Secondly, inappropriate use. This means to prescribe antibiotics in a way that is not optimal for killing bacteria, such as matching the wrong bacteria to the wrong antibiotic. This allows some bacteria to survive and pass on their resistant genes. In fact, studies have shown that treatment indication, choice of agent, or duration of antibiotic therapy is incorrect in 30% to 50% of cases. Thirdly, antibiotics are widely used in the agricultural industry. They are used as growth supplements in livestock to prevent diseases and increase quality, and an estimated 80% of antibiotics are used in animals. This increased exposure of microbes to antibiotics increases chances for some of them to develop resistance. Fourthly, there are very few new antibiotics. This is because antibiotic development is no longer considered an economically wise investment for the pharmaceutical industry. This is due to the inevitable eventual microbial resistance to these new drugs, which renders them useless and non-profitable in the long term. So many pharmaceutical companies abandoned the antibiotic field. After microbial resistance develops, there are several key pathways it can spread in the environment. Firstly, bacteria can spread from one person to another through direct as well as indirect contact. Secondly, bacteria may be spread between animals and humans as people come in close contact with animals in their daily life. For example, we keep pets at home and raise animals for food. Thirdly, through food and water. During slaughter or when processing meat, bacteria can be transferred to the final product. Also, bacteria can spread via water used for irrigation, washing cutlery, etc. With international trade nowadays, bacteria can potentially be spread with any meat, fruits, vegetables, seeds, or grains that are being imported or exported. And every day, several million people fly by plane. If someone carries a resistant bacteria, they can bring it along and spread it to another country. And lastly, and ironically, healthcare facilities are hotspots for resistant bacteria. This is because many sick people are in close proximity to each other and antibiotic usage is high. We may better understand the global situation regarding antibiotic resistance through case studies. Most bacteria are classified into gram-positive and gram-negative based on the structure of their bacterial cell walls, but some bacteria are not classified as either gram-positive nor gram-negative due to their different characteristics. For this reason, different antibiotics are required to combat different bacteria. This results in diverse antibiotic resistant strains. In this presentation, we will discuss two different types of resistant bacteria, including one gram-negative one and one neither positive nor negative. The first case we will discuss is KPC. KPC stands for Klebsiella pneumoniae carbapenemase. It is an enzyme produced by the Klebsiella pneumoniae bacteria, which is a gram-negative bacterium. Carbapenems are strong last-line antibiotics, and KPC can break it down and make it ineffective. KPC was first discovered in the US in 1996, and it has since spread across the world. Due to most resistant bacteria exhibiting only low-level resistance, KPC is very difficult to detect. Resistant strains can go undetected until they gain higher resistance, which is already too late. As we can see here, in the US in 2017 alone, there were 8,500 KPC cases in hospitalized patients. It caused up to $280 million in healthcare cost and up to 700 deaths. KPC is so dangerous because the mortality rate is up to half if there's a bloodstream infection. This is because so few antibiotics remain that can kill the bacteria. Furthermore, KPC is already spreading globally. The first known case was in 2013 in New Zealand, but as we can see on this map, with red indicating endemic origin, it probably did not originate there. Due to international travel and many refugees from war and global disasters, bacterial strains can be spread all over the world very quickly. The second case we will discuss is tuberculosis resistance. TB bacteria can be resistant in two ways, moderately or extremely. Resistant TB strains requires multiple drugs to treat. For the moderately resistant type, it is resistant to 2 of the 4 first-line antibiotics. As for the extremely resistant type, first-line antibiotics are useless against it. It is even resistant to 1 of the 3 second-line antibiotics. The only way to kill resistant TB is to use mixtures of antibiotics to prevent further development of resistance, but many of these mixtures are toxic with severe side effects. As we can see, there are estimated 10 million cases of TB in the world each year. Without proper treatment, it kills almost all HIV-positive people and 45% of HIV-negative people. Also, up to 13% of new cases are multi-drug resistant. The treatment prognosis for resistant TB is rather bleak. Moderately resistant TB has only barely more than half treatment success rate, while extremely resistant TB has barely a third of the chance. The situation is made worse by how easily TB is spread from person to person through the air and from dust. Furthermore, mismanagement of the moderately resistant TB can result in creation of the extremely resistant type. As we can see from this map, nearly the entire globe has been exposed to TB of moderate resistance. If healthcare practices are not optimized to fight against antibiotic resistance, many more extreme resistant TB strains can arise. As of now, 123 countries have already identified at least one extreme resistant TB case. As we can see from the case studies, without proper prevention and control, antibiotic resistance can potentially be catastrophic to human life. Since the factors contributing to antibiotic resistance are spread throughout different sectors of society, in order to effectively prevent and control the spread of resistant microbes, it is necessary for all sectors to work together. Here I will talk about each in turn. Firstly, for the policymakers, in 2015 the WHO enacted the Global Action Plan to combat antimicrobial resistance. This plan has 5 objectives. 1. To improve awareness and understanding of antibiotic resistance. 2. To strengthen knowledge of antimicrobial resistance through surveillance and research. 3. To reduce the incidence of infection. 4. To optimize the use of antimicrobial agents. And 5. To increase investment in new medicines, diagnostic tools, vaccines, and other interventions. After the WHO enacted its action plan, other countries followed by adapting their own systems to achieve the objectives listed in the WHO action plan. For example, the UK formulated its 20-year vision and 5-year plan, and China came up with its 2016 to 2020 National Action Plan. Both of these visions and plans have goals in accordance to the WHO Action Plan. Secondly, on the individual front, we should use antibiotics wisely. So that means we should always go to the doctor when we feel unwell, never attempt to self-medicate, and always follow the doctor's instructions in taking our medicines. Secondly, we should try to stay healthy. So that means having good hygiene habits such as washing hands and cooking food properly, getting vaccinated, and also, when we are sick, we should put on masks and avoid going to crowded places where we may spread our germs. And lastly, we should raise awareness of the issue by learning more about antibiotic resistance ourselves and teaching others what we learn. Thirdly, for healthcare professionals, they should only prescribe and dispense antibiotics when it is needed according to current guidelines. Also, to prevent resistant bacteria from being carried from healthcare facilities to the outside, they should minimize their own exposure by ensuring that their hands, instrument, and environment are clean. And most importantly, they should report any antibiotic-resistant infections to surveillance teams. Fourthly, for the healthcare industry, they should invest in research and development of new antibiotics, vaccines, diagnostics, and other tools. It may not be easy to motivate them because, as mentioned before, development of new antibiotics is largely deemed unwise investment, so governments can chip in to give in some monetary incentive here. But anyway, an example of a successful new antibiotic developed is tedazolid here. Tedazolid is actually a structurally modified version of an original antibiotic called linezolid. It is an antibiotic used to treat gram-positive infections. But bacteria has developed the mechanism to circumvent linezolid. So, the pharmaceutical company which owns linezolid invested in R&D, and they developed tedazolid by changing the linezolid molecule's side groups. Here, we can see a substitution. This change made the bacteria no longer able to recognize the drug, so resistance is averted. And here, we can see the addition of a side group. This change actually increased the antibiotic's effectiveness, resulting in a stronger, better antibiotic. And lastly, for the agricultural sector, at present, 95% of antibiotics used worldwide are put into animal feed and water. Not only is this bad because it provides a great environment for resistance to develop, it also makes treatment of individual animals very difficult. Furthermore, of these 95%, 96 were sold over the counter without any veterinary diagnosis or involvement. This lack of regulation should not be allowed to happen. The use of antibiotics in agriculture should be monitored strictly by veterinarians, and policies need to be put in place to enforce this. Furthermore, alternative farming methods such as measures to improve hygiene and reduce crowdedness, or even alternative growth promoters, should be encouraged to reduce antibiotic use. And finally, to conclude our presentation, in historical times, before there were antibiotics, humans died from many conditions for which death is rare nowadays. Can you imagine dying because you got a scratch on your arm? That was actually rather common. 1 out of 9 people died this way. Without antibiotics, there would be a high risk to all surgeries that includes medical treatments which install devices within the human body, like catheters and heart valves, for example, so many now treatable diseases can no longer be treated. Burns and other injuries will become very, very dangerous, such as even a skin break as small as an insect bite can potentially kill you. There will also be dramatic changes in our food supply because antibiotics are widely used to promote growth of livestock and crops. If antibiotics lose their power, we can potentially run into a food shortage problem. As we can see, antibiotic resistance is a huge threat to humanity. Therefore, there is an urgent need to raise public awareness of the issue of antibiotic resistance and preventive measures, tightly control current use of antibiotics, research and develop new antibiotics and treatments, and cooperate on a multi-sector and international scale. Only this way can we ensure that our future generations can enjoy the medical advances that we have today. And this is the end of our presentation. Thank you for listening.